Hello students, welcome to Maths Online Academy by Sandhya, myself Sandhya. And already we finished chapter 1 real numbers, chapter 2 polynomials. And the next chapter is chapter number 3. Chapter name is pair of linear equations in two variables. Let's see the chapter name. By the chapter name we get the some concepts. Okay, the name pair of linear equation. See, linear equation. What is the linear equation? Linear means, if we are saying linear equation means the degree of equation is 1. So the degree should be 1. See the examples. 3x plus 1 equal to 0. This is also linear equation. And 3x plus 1 equal to 2x plus 2. Is this linear equation or not? Yes, this is also one linear equation. This is also linear equation. This is also linear equation. Okay? And see, 3x plus 5 equal to 6. This is also linear equation. Okay, this is linear equation in how many variables? Only one variable. So this is linear equation in one variable. Yes, this is linear equation and with only one variable. Okay, only one variable. And some more example, let's say 3x plus 5 equal to 5. How many variables are here? 2. So this is called linear equation, two variables. Okay. 4x plus 5 equal to 6. This is also linear equation. This is also linear equation. But linear equation in two variables. Okay. 4xy plus 3x plus 4y. Is this linear equation or not? No. Y means here how many powers? 1, 1, 2. So this is not a linear equation. That degree must be 1. This is not a linear equation. These are only linear equations. Okay. If you draw the graph should be straight line. If you draw the graph for linear equation, that is in straight line. That is in this like this or like this, anyone. Means if you draw the graph, the solution of the linear equation is in straight line. Okay, in this, see, in this same, let's take, if you take the different linear equations, we get the some little bit concept. This is one linear equation, and again 3x plus 2y equal to 5. Here directly we get the x value is, for example, we have to prove RHS equal to LHS. So when you substitute the x value, you get the LHI. When you let's take two examples. X plus 3 equal to 5. Here when you substitute x value equal to 2, you get the LHS equal to RHS. This is LHS and this is RHS. If you substitute x equal to 5 minus 3 and x equal to what? 2. If you substitute x equal to 2 value here, you get the LHS equal to RHS. Means here we have only one solution. Okay. This has only one solution. Okay, this one has only one solution. Why we are taking this one means, based on getting the solutions, we have three types of linear equations. Pair of linear equations, na? That is, this has only one solution. For example, here x plus y equal to 5. X plus y equal to 5 means we have to substitute x equal to, for example, we are substituting x equal to 1 means y equal to become 4. X equal to 0 means y equal to 5. Here we have how many solutions? So many solutions. If you substitute 0 next to 2, 3, 4, like that, na? You can substitute x equal to -1 and y equal to -2. In this, we get the so many solutions. Means here have infinite solutions. Infinite solutions. Here we have infinite solutions. Okay. When linear equation is in this form, this is has only one equation. When this is in this form, that equation has infinite solutions. Okay. You remember this one. And here mentioning pair of linear equations. Okay. Pair of linear equations. Pair of linear equations means 2. X plus y equal to 5 and some 2x plus 3y equal to 6. These two called pair. Na? Pair means 2. This is 1 and this is 2. Pair of linear equations in 2 variables. Pair means 2 equations in 2 variables, and that is in linear equations. Okay, we got the one pair of linear equations in 2 variables. This is the one. For example, we are taking the 2 equations. What happens? If we take 2 equations, if you draw the graph, what happens? Okay. Let's say if you draw the graph to the above pair of linear equations, what happens? Means graphical solution of pair of linear equations. Okay, pair of linear equations. Pair of linear equations. So, in case 1, what happens? If we take the 2 linear equations, when you draw the graph, what happens? Case 1. This is the graph, na? For example, this is one graph for first linear equation, and one more is like this. Okay, this is L, this is M. For example, we are taking this is the graph of the first equation, this is the graph of the second equation, linear equations. So what happened here? Intersect. Intersect means how many solutions? Only solution, intersecting at only one common point. Means only one solution. Here we get the only one solution. Okay. And what happened here? Intersecting lines. Intersecting lines. Okay. Only one solution and intersecting lines. Okay. Second one. Case 2. Case 2. In this equation, for example, 2 lines are like this, parallel. L, M. 2 lines are parallel and they are not intersecting. Means not intersecting means these are parallel lines. Parallel lines. These are intersecting lines. This is one point and this is second point. interline. This is the, see, parallel lines. And how many solutions? There is no solution. Those are not intersecting. Na? We don't have common points. So, no solutions. Next, case 3. If we have a two linear equations, when you draw the graph, what happens? And in this graph, for example, two lines are, this is the first line, L. And one more line is here only, on the first line. Means coincide. Coincide. This is M. Coincide means those are coincide lines. Coincide lines. Okay, coincide lines means how many solutions? Infinite solutions. Each point is solution. Na? Each point is solution. So, infinite solution. Infinite solution. This is the case 1. When the two graphs means two linear equations graphs are intersecting, only one solution, intersecting lines. Those lines are parallel lines, no solutions. If coincides means coincide lines, infinite solutions. Each point is solution, so infinite solution. Based on that, and this is consistent solution and inconsistent solution. Two types. Consistent and one more is inconsistent. Inconsistent pair of linear equations, consistent of pair of linear equations. These all are pair of linear equations. Pair means two. If you have in one system two equations are there, means two linear equations are there, means that is pair of linear equation. So this is, if that pair of linear equation has at least one solution, those are called consistent. If that pair of linear equations don't have any solution, that is inconsistent. Means this is consistent. Yes, na? This has at least one solution. At least one solution means this is consistent. No solutions means inconsistent. Okay, inconsistent. And this is infinite solution. We want only at least one solution. So this is also consistent solution. Okay. See, remember all this consistent, inconsistent, parallel lines. Those words are very important in the entire chapter. Why means we use the in the questions they ask this is consistent or inconsistent. You remember what is the consistent, what is the inconsistent. Consistent means that pair of linear equations have at least one solution, means that is consistent. If that pair of linear equation doesn't have the solutions, means that is inconsistent. In the entire chapter they ask show that this pair of linear equations are consistent or inconsistent. Like that, these are parallel or intersecting. Those are coincide lines, or in many ways they ask. Okay, remember these words. Okay, for intersecting lines, how many solutions? For parallel lines, how many solutions? For coincidence lines. Okay, this is enough. And for next, we are discussing pair of linear equations. Pair of linear. Every time we are taking some example, take x plus y, 3x plus y. Why we are taking x plus y equal to something, 3x plus y. Here also we have general form of the pair of linear equation. So, general form of pair of linear equation. Here, na? Here we are, the chapter name is pair of linear equation. So the general form of pair of linear equations. Pair of linear equations in two variables. That is also important. Two variables. Okay. See, pair means two linear equations. a1x plus b1y plus c1 equal to 0. This is the question 1. This is the equation 1. a2x plus b2y plus c2 equal to 0. This is the equation number 2. Okay. What are the questions here? Relation between the coefficients of a pair of linear equations. Okay. Actually, this is the general form of pair of linear equations. Okay. Next, this is the very, very important relation between the coefficients of a pair of linear equation. See, relation between coefficients. Now, what are the coefficients here? A1, coefficients of pair of linear equations. Okay, pair of linear equations. What are the coefficients? A1, B1, C1, A2, B2, C2. These are the coefficients, and C1, C2 are the constants. Okay, coefficients of the x and y. Okay, for example, first A1 by A2 equal to B1 by B2. For example, these two are not equal. What happens in graph? Those are intersecting lines. Intersecting lines. Okay, these are intersecting. Intersecting lines means that has only one solution. Already we discussed. Intersecting means like this, na? Intersecting means that has the one common point, means has only one solution. And what are those? Consistent or inconsistent? Consistent. Okay. If A1 by A2 not equal to B1 by B2 means intersecting lines, only one solution, consistent. Next case. Case number 2. For example, in case 2, in case 2, A1 by A2 equal to B1 by B2. Up to this, these two are cleared. Means let's take another terms are what? C1 by C2, na? Not equal to C1 by C2 means these are parallel lines. Parallel lines. Okay, parallel lines means no solution. Yes, parallel lines means no solution. No solution means inconsistent. This is inconsistent. Okay, up to clear. And next case 3. Next case 3. A1 by A2 equal to B1 by B2 and equal to C1 by C2. If both A1 by A2, B1 by B2, C1 by C2 are equal means those are coincident. Coincide lines. Coincide lines. Coincide line means infinite solutions. Infinite solution means what? Consistent. Yes. Based on these conditions, directly if you know the pair of linear equations, by using the conditions you can say that is parallel, coincidence, linear, intersecting, or no solution. You can find out anything. Okay. If you like this video, please share and subscribe. Thank you.